Hello and welcome to Desktop Robotics first lesson. Today's lesson is on the basic parts of a computer. So every computer you'll ever use will have these basic parts and these are just good to know. You don't really need this stuff for anything specific, but it'll come in handy for just like programming especially and working with electronics and pretty much everything. So the first part I want to talk about is the CPU. So the CPU is the brain of your computer. It pretty much does all the calculations on your computer except for graphical calculations, which I'll go on to later. So it comes in a lot of different shapes and sizes. You can find huge ones in a supercomputer. You can find tiny ones in a calculator, and they vary a lot basically. They're made up of transistors. So transistors are basically very very small switches. So they're very small. They're like nanometers thick, and one CPU will have billions of transistors. It's insane. And the way a CPU is designed is called an architecture, and this dictates what kind of software can run on it, and also what kind of applications the said CPU is being used for. So, an x86 processor is something that you'll find in your computer. So, in your tower desktop or a laptop, you'll find an x86 CPU usually. These processors are older. They're legacy. They're mostly only made by Intel and AMD nowadays, because those are the only two companies that are actually able to license it. They're they take up a lot of power, but they're not as efficient as something like an ARM processor, which I'll get into right now. An ARM processor is like a much more power efficient processor, which are found in usually more like in low power devices, so something like a camera or especially nowadays in your phone. Um, some computers are actually switching to ARM, such as Apple's new computers right now. They're the M1 chip. Those processors are actually using ARM processors, so it makes them a lot more efficient. In something such as a laptop, for example, the battery lasts a lot longer because ARM chips don't re- produce as much heat as something as a x86 chip would. A GPU is a part that specifically focuses on video and graphical calculations. So this is stuff that CPU can do, but separating it from a CPU into a dedicated place is just a much more efficient method of doing things. A lot of the time you'll have a GPU especially embedded in the CPU itself. It's called like integrated graphics. But when you're doing things like video editing or simulations, you want to have a dedicated GPU, something that can focus on that mathematics that are special in video type of stuff, and something that's more efficient at it as well. And it often has its own memory, which is called VRAM, and usually it's just a place for video and textures to be stored before it's processed. The next parts, well, two parts technically, is the permanent storage and the RAM. I'm going to go into the RAM first. The RAM is a temporary memory. It's analogous to something like a short-term memory. It's very very fast, which is the real advantage of it, because you can just instantly get something in and out of it. But the problem with it is that it requires power every time data is stored on it. If the data is if the, I'm sorry if the power is lost, then the data is completely gone on it, which means it's not really suitable for something permanent. But that's why we have something like a hard drive or SSD, which has storage on it permanently. Although this is not as fast as RAM, so they're not necessarily the first line of storage, I guess you can say. They're definitely there for stuff that you'll need in the future, but you can't afford to lose just after a reboot. The process of loading is actually when a program will take data from your hard drive or SSD and put it into your RAM. So that means it'll take the storage file that it needs from the slow drive and make it somewhere very accessible and put it somewhere where it can easily access it. The motherboard is a circuitry that connects basically everything together. So you can think of this as something like the backbone or like the spinal cord. This will connect all the parts of your computer together and make it actually work. Uh, there are two main parts of the motherboard that you probably don't need to know, but it's nice to know: the north bridge and the south bridge. The north bridge controls stuff that's very high priority, something that needs to have very quick connection. This is like the connection from your CPU to your RAM or your CPU to your GPU. That's the stuff that the north bridge handles. The south bridge is less. It manages less priority stuff. So things like USB. It's not an absolute utmost priority that your flash drive has to be connected to your motherboard. But of course, it does need regulation. It does need to be able to actually communicate like efficiently still. And the last part of a PC we're going to talk about today is a power supply unit, which converts the 120 volt AC power from your wall into something that your computer can use. So computer parts are very, very sensitive to electrical changes, right? They need something reliable and they need something consistent, or else it will just not work correctly. A power supply unit will take the uneven, unreliable mess of power that your wall gives and convert it to something that the motherboard and all the process parts in your computer can handle, first off, and second, just count on. So the voltage that the wall gives you is 120 volts AC, which is alternating current. That's not something your computer can just handle outright. If you try to plug in a computer into the wall directly without a power supply unit, it'll burn it. So don't do that. So a computer will usually want something like 12 volt DC, which is a much lower number than 120 volts, of course. But a power supply will take that high voltage and drop it down to something that the computer can't handle, and just makes that AC alternating current, so the voltage goes up and down, and it makes it something just a clean line that the computer can handle. And this is done using capacitors in the computer, in the power supply. I'm sorry. It's kind of really cool. It using a bunch of capacitors and clever circuitry that I don't know. It is able to basically clean the power. And peripherals is not a part of the internal of a computer, but it's stuff that is good to know. This is basically anything external of your computer. So it's your monitor, your speakers, your keyboard and mice. These are needed to interact with the computer, so these are human interface devices, but they're not explicitly needed for your computer to work and function. So they're useful for a human to use it, but there are computers out there that have no humans operating it. That's like a server, for example, will usually be self-sufficient because it needs to be able to do whatever it needs to do without anyone always using it. Of course, that's the point of a server. So servers usually you'll remote into, you'll connect through the internet and through the network, but that's a different story. So thanks for watching. This was the first lesson, and hopefully you enjoyed it.